Alright, in this video lesson we are going to learn how we can do modeling problem with a sinusoidal function over here. And so this lecture we're going over here is one of the applications. I'm showing one of the applications of how we can use a trigonometry in our daily life. Alright, so throughout the lesson here, allow me to bring in the idea, the fundamentals throughout the demonstration problem. So I'm going to go through a couple of demonstration problems to illustrate the ideas, and then throughout those we're going to be able to identify and then generalize the fundamentals so that we can then apply that to any other modeling problem with so that we can model with the sinusoidal function. Okay. And so, needless to say, this is an application. This lesson is all about how an application. So you are required to have mastered all of your skills in trigonometry, including being able to graph and understand what a trig function is, and all of those, etc., and the identities and all of that. Okay. So let me now swing over to the computer screen, and we're going to bring up our one of our problems here. Alright, so in this problem right here, let's look at the given information that we have here. So at midnight, the tide is at the mid-tide of 13 feet. At 6 a.m., the tide is at the high tide of 21 feet. And at 6 p.m., the tide is at its low tide of 5 feet. And it takes 24 hours for the tide to complete a full cycle. So in this problem here that we're about to do, and I didn't even get into the actual question yet, but according to the data that we have read so far, then the idea is that it's about anything that's going in a cycle. Okay, so that's the already leading idea right here. So generality, as a generality, any quantity that changes as a cycle. Okay, in a cycle, and we can use a model, a trigonometry function, a sinusoidal function, specifically to model that quantity like that. And so further on the wording of the problem, now we want to, yes, part A of the problem, we want to determine a sinusoidal function that models the tide height, h, as a function of time, t, in hours. So before we really get into tackling down determining the modeling function being a sinusoidal function right here, I just want to mention that, so the picture that describes the situation is here. So we have low tide, high tide, and mid tide. That's what these terminologies mean right here. And so this is just a general idea. The tide, right, it goes high, it goes low, and it goes mid tide. All right, so after reading the wording description of our problem right here, allow me to bring in how I would do it, okay? Because when it comes to this kind of problem right here, we can approach it in so many different ways right here. So allow me to bring in how I would personally do it, okay? And so, of course, the time axis is going to be a horizontal axis right here, but I'm not going to rushly draw that yet. Think about the vertical height, the height of our tide right there. I'm going to call that some vertical axis, and that's the height here. And like I said earlier, I'm not going to rush into drawing down the horizontal axis for the time right here. Okay, and then right here, and you can think about making it as a connection with the picture you have seen on the computer screen earlier. Then the vertical axis here is corresponding to the post, the vertical post where the tide is going up and down and mid tide and all that throughout the day, and then keep repeating that cycle. Okay. And so now, here's the next step that I'm doing. I'm just going to simply pick a point. I call that high tide. So just like that picture you have seen earlier, there's a high tide, there's a mid tide, there's a low tide. So high tide here, now I put in a label, 21. Okay? And then the low tide, right here, I put in another label. According to the problem, we got a 5 right here. Okay? And so mid-tide, and in the way it's meant to be exactly in the middle between high tide and low tide, right? So that's the way how we understand about the tide right there. So when it says mid-tide, it's exactly in the middle. And so exactly the middle right here, okay, and it's for us here. And of course, I'm going a little loose in the scales right here, but please forgive me about that. But 13 being right in the middle. And so checking for consistency as far as this physical distance, yes, from 13 to 21, it's 8 up. And from 13, the mid-tide down to the low right here, it's 8 down right there. So 13 makes sense to be exactly in the middle. Okay? And so now I have not put in the horizontal time axis. So I'm going to put that here. But I'm going to put that as dotted line. Okay? So this is my time axis, but I put it right at the mid-tide right here. So the idea of the mid-tide here, the idea of the mid-tide is that it's exactly halfway between the highest point and the lowest point, like that. Okay, and so now here's my next step. I am going to start gathering the information that was given from the problem and put that as a plot right here. So, like I said, we have a t-axis now, but it's a dotted t really because it means really it's not purposely placed at the 0 on the scale right here, but it's just something going horizontal. Okay, so now let's gather the plotting points, the data from our problem, and put it on the graph here as a plot. All right, so now at midnight, the tide is at mid-tide, 13 feet. So midnight, the tide is at mid-tide, 13 feet. I can just simply put that down as a time point, just a time point here, okay, as a time point. And I call it midnight. So midnight is famously known as 12 a.m. midnight. So it's right now all I'm seeing is a time point, and how much distance from that from that point to the vertical h-axis, that's not important. We just simply put it there. Okay. So at midnight, the tide is at mid-tide. So I put that point right on spot right here when the height is 13. I put it right here. Okay. So I have a point right here. That point now is going to be at midnight, right, being a 13. Okay. Now let's put in my next point of data at 6 a.m. So you can think of this as 6 a.m. comes after midnight. So at 6 a.m., the tide is at high tide, 21 feet. At 6 p.m., the tide is at its low tide, 5 feet. And it takes 24 hours for the tide to complete a full cycle. Okay? And so let me now bring all of this information, all of these data into the actual graph. So in how I'm seeing it, I'm going to tackle right down on the complete cycle. So that means the tide will be at mid-tide every midnight. Okay, so that means from this time point being at 12 a.m. right here, let's say I set my space about this much. Let's call that one complete 24 hours. So that's a 12 a.m. of the next day. Okay, that's the 12 a.m. of the next day, and that means the tide will hit exactly same height again, right there. That's why I put that point right there. So I have put down two plotted points, the start and the end of our cycle, and then that's also the beginning of a new cycle. Okay, and so we've seen that earlier on the computer screen at 6 a.m. and the whole space right here is a 24 hours space. 24 hours time length right here. And so 6 hours means, 6 a.m. is 6 hours away from, you can think of that, 6 a.m. is a 6 hour away from, or 6 hours after that time point, 12 a.m. right here. And then it is going to be a quarter of the whole the period right here. And so halfway, quarter. So halfway right here makes sense to be just exactly at 12 p.m. Okay, whether the problem really mentioned about it or not, that's not important. But now 12 p.m. has to be exactly halfway between a midnight and to another midnight. Okay, and then so that means what? 6 a.m. is exactly halfway between the 12 a.m. and the 12 p.m. that comes right after. And so at that 6 a.m. right there, at the 6 a.m. we already had a data point. The tide hit a high at 21. So right here I'm going to put a point right here. So right here at 6 a.m. I have a high tide. Okay, so I don't put that point on this line right here, but I put the point up here. Okay, and so we didn't, and really again, you have seen through the wording of the problem, there was nothing mentioned or stated about the 12 p.m., but we just know easily enough that 12 p.m. is exactly halfway throughout our full cycle. And so now, but the problem did mention that at 6 p.m., so 6 p.m. is exactly halfway between 12 p.m. to the next midnight. All right, or the midnight to the next day, like that. And so here, that's 6 p.m., and now that's just a time point, not the plotted point yet. I'm putting that down 6 p.m. But now we realize 6 p.m. is the third quarter throughout this entire period. Okay, and so in this way right here, now the wording was saying at 6 p.m. the tide hit the low tide being 5. So 5 is down here. So we have the actual plotted point appears right down here. Okay. And so really, according to the data that we're given, then we only have this plotted point, that plotted point. We didn't have anything here. We have that plotted point, and we swing back to that plotted point. These are the plotted points like that. Okay. And so now with these plotted points, here's how I'm doing. And I now should mention also as together with this. In the way I'm doing it, for now, I chose to let the midnight, okay? I chose to let midnight be the starting point of our period, of our complete cycle. And so the starting point means we can also refer to that as t equals 0 right here. So at this midnight, we call that as t equals 0. Okay? And so that means right here at that next 12 a.m. of the 12 a.m. of the next day, the midnight of the next day right there, we call that t equals 24. So right here it means t equals 24 because I chose midnight to be a starting point. Okay? And then later on I'm going to come back and explain some further detail. But so now with this starting point and this ending point, right, and the t equals 24 now has become the ending point. So now, after getting those points right here, here's how I'm doing it. After putting in the plotted points, I'm going to try to fit a sinusoidal, because now we already can kind of start seeing the nature going up, going down through the center line, right? That mid-tide right here now can be regarded as a center line. So looking from the left to the right, I'm seeing my graph right here as from the starting point, it's rising up, falling down, right? And fall down to the bottom, to the low tide right here, and swing back up. So now in that way, I'm going to try to fit. All I'm saying is we're trying to fit. We don't have to be exactly on scale, but I'm going to try to fit. So fitting in, I can see that I can fit in a sinusoidal function that is going like this. Okay. All right. And of course, we didn't really plot these nice points, these other nice points that create the nice bent curve, but just these plotted points are good enough. And so now, what about the 12 a.m.? It has to go through the center line, right, and hits back so that it can hit down to the low. So that's why even though the problem didn't mention, we still can just simply understand that at 12 p.m. it has to go through the mid-tide again. Okay, and so now clearly after fitting the shape right here, I now recognize the graph here is a sine function. The basic structure here is a sine function. But now keep in mind again, I chose to let midnight, according to the data given. The data is just the data. I chose to let midnight be the starting point. And so in that way, one complete cycle means when we hit to the next midnight, it's one cycle, 24 hours. Because 24 hours is what's stated in our problem, in the wording of our problem, as the full cycle. And so in that way, right here, every 6 hours, see? So from the first midnight that we chose, right, to the first 6 a.m., that's 6 hours away, that's 1/4 of the way. So 12 p.m. is exactly halfway. The next 6 p.m. right here, another 6 hours away, that's the third quarter, that's where, and according to the plotting data, according to the data that I plotted, it appears to be hitting a low. It hits a high at the first quarter, it hits a low at the third quarter, it crosses through at the center line. And so I'm treating mid-tide right here as the center line. Okay, and so now once I try my best to put in a fitted curve right here, and now I recognize this shape right here can be regarded as a sine function. Okay, as a sine function. So now we must have learned about how we go from a graph, from a sinusoidal graph, and to come up with a function. Okay, so to come up with a function. So in that way, we have to utilize that skill. We have to bring in that skill right here. Now with this basic unit, like I said, we purposely chose a t equals 0 for this midnight. And then t equals 24 here. So in this graph right here, the familiar skills you will see coming back. I have a center line for this graph. This graph has a center line at, see, y equals this midline, this mid-tide right here is now graphically acting as our center line, y equals 13. Okay. Our sine graph right here that we chose has amplitude, or the wave heights. See, from mid-tide to 21, it's 8 spaces up. From mid-tide to hit the low being 5, it's another 8 feet down right there. So the amplitude in the end is 8. Okay, and so that's how immediately I can come up with the following. So provided that we have seen the picture being a sine, it has to be the amplitude 8 times sine of some, and in my style I will always be putting that coefficient a in and then multiply with an in parentheses x minus the starting point. And so you can always refer back to the lecture we've learned earlier about how we can identify a sinusoidal function from a given sinusoidal graph like that. But now the mid-tide determines our center line, so that's plus 13. All right, so now let's just simply find the value for a and the starting point. For this graph, as I said earlier, we can always, it's an application problem, so we can always purposely choose the starting point to be the time point t equals 0. So that means what? Further information I have. The starting point is at t equals 0. And further, in this graph right here, and according to the wording description of the problem right there, the graph completes one cycle every 24 hours. So that means the period is p equals 24. Now I have gathered some more important information here. Let's swing over to the other board. And so now in this way, here's how I'm seeing it. Period for any sine function. Recall from the previous learning about the sine function. Period for any sine function is famously 2 pi over a, the coefficient that I put here. Okay. But for our particular function here, we already knew that the period equals 24. 24 hours, 24 days, or 24 whatever, right? So here in our particular problem, it's 24 hours. But that means we are going to equate 2 pi over a with 24 here. Okay, and in that way, I am going to solve for this. I am going to solve this equation for a right here, and that leads to a must equal 2 pi over 24, which reduces down to pi over 12 like that. All right. And so after we have solved for the value of a right here, now we have more value to complete into our equation. So y equals 8 sine of, now a is found to be pi over 12. So we're looking at pi over 12 times t minus c, where we have been understanding that c is the indication of the starting point. And we have chosen, and I listed on the other board right, that we have chosen that the starting point is t equals 0 as the starting point. So I'm going to substitute this. I'm going to substitute this into our starting point c right here. So that means our equation now is completed as y equals 8 sine of pi over 12 t plus 13. And at this point right here, we have completed our the sinusoidal function. That's one way of how we have obtained how we have come up with the model, the sinusoidal function as a way to model that. But that, like I said, it's just only one way. All right, and so now after we have done part A, where we have come up with the modeling function as a sinusoidal function for this data right here, then the next task that we want to do, let's find the tide at 7 p.m. of the day. And so that is the whole point of being able to come up with a modeling function. The whole point now is that once we have come up with a modeling function, we can use that to predict the height. In this particular problem right here, we can use that modeling function to predict the height of the tide at any various time point of the day. Okay, and so now that our modeling function is found, recall that the starting point t equals 0 is at midnight. So back on this plot right here, midnight is right here. That's our starting point, t equals 0. So 7 p.m. is somewhere past the 6 p.m. point right there. And that means it's going to be, so that's 12 hours away. That's 18 hours away, 1 more hour away, and that is exactly at 7 p.m. My point now is that 7 p.m. now, according to that chart, according to how we set our starting point in 7 p.m. is the same as, leads to the understanding that time, right, equals 19 hours after that starting point, midnight, right? And so now, once we have understood properly that time point 7 p.m. to be t equals 19, then the question on the problem here of the problem asks us to find the tide at 7 p.m. of the day, and I mean find the tide height, right, at 7 p.m. of the day. But in this concept of our function, it really means the height of the tide is our function h of 19. So now I'm just going to simply substitute as t equals 19 into our function, and that will come out with 8 times sine of pi over 12 times 19 plus the 13. And of course, all of these values right here, let's go ahead and run them in the radian values again. Okay, and so now with the calculator, we type it in 8 times sine of, open parentheses, second pi over 12, close the parentheses, and multiply with 19 in parentheses. And in another parentheses to close the sign, and we're going to add with 13. So it comes out 5.2725 and a lot longer. And so to make it simple, I'll just round to 2 decimal places in this lecture right here. So that's making it, the height at 7 p.m. is predicted to be 5.27 feet. And that's how we have come to our answer. And so now, before we close down completely with this problem, allow me to bring in another alternative right here. And that really opens up a good generality about when we're doing the modeling a problem using a sinusoidal function. Now, if you're looking at the wording here, when it says midnight, we don't have to start with midnight at the starting point of our graph. And further, we don't need to change any of the data given here. Think about it. Now, at 6 a.m., it's just the way how it says now, at any time for any day, at 6 a.m., the tide is going to hit 21 feet. And then let's assume that in this problem right here, then there will be no change to the tide height at all throughout the year. So that means what? Every day is the same as any other day. And so midnight right here doesn't necessarily have to be the starting point. It just basically means at any midnight of a day, the tide will hit 13 feet. at any 6 o'clock in the morning of any day, the tide will be at the high tide of 21 feet, and so on and so forth. And so at 6 p.m. of any day, the tide will be at its low of 5 feet. And then once again, this information here remains permanent, 24 hours for the tide to complete a full cycle. So now, back on this graph right here, think about it with all that exact same given data right there. What about I chose 6 a.m.? Okay. What about I chose at 6 a.m. point to be the starting point? All right. And so now on this timeline right here, and again, I'm putting that dotted timeline right on the mid-tide line right here. So this time starting point right here, that time point, I call that 6 a.m. And I completely ignore about the midnight or whatsoever. Okay, so let's call that 6 a.m. being our starting point. Then so in the way how it is, it has to take 24 hours. It has to take 24 hours to complete one cycle of the tide. So that means at the 6 a.m. exactly of the next morning, at exactly 6 a.m. of the next morning, that will mark 24 hours total time to complete the one cycle. And so now halfway between that will be 6 p.m. And so in that way right here, midnight will have to happen here. Some midnight will have to happen here. 12 a.m. Some midnight. Okay? And right here, exactly halfway between 6 a.m. and 6 p.m., that has to be 12 p.m. Some noon, the noon of some day, of that particular day. Okay, and this is midnight. And like I said, my point now is that we can actually choose our starting point according to the given data. Okay, and then you will find out how this will completely change, but it won't change the answer. It will just change the way how the function looks, but it won't change the answer. So now here's the thing. Let's put in our plotted point right here. So at 6 a.m. we do have given the data. So at 6 a.m. the tide is at it's high tide, 21 feet. So I'm starting with a high point. We were not told anything regarding at exactly 12 p.m. So I'm leaving it there right now. But at 6 p.m. the tide hits a low at 5 feet. So it hits down to a low, and once again notice 6 p.m. is exactly halfway between the starting point and the ending point. And then at midnight we are right at the mid-tide. So I have a plotted point here, I had a plotted point here, and I've just now made a plotted point here. And think about it, needless to say, right exactly at one complete cycle away, at that 6 a.m. of the next day, the tide has to hit high again at 13 feet. Okay? And so now in that way, I'm seeing that from this point to that point, and the change is supposed to be steady. So it has to be as a process. I'm seeing that I can fit in the following curve. And now I recognize that as a cosine, even though it's the exact sinusoidal graph right here, but starting with choosing a different starting point right here. See, and even though this point here was not specifically stated, but the change here is supposed to be steady, and so it has to go through that mid-tide before hitting down to the low right here. And so now in this way, how it looks right here, the function starts out high, drops through the center line, drops down to a low, and hits back and comes back to the high right here. This shape right here is recognized now as a cosine. So in that way, I'm going to immediately write down the sketch of our function. Y must equal some amplitude times cosine of a times t minus the starting point plus with the center line k value. Okay. And now, once we have set our goal for this particular direction that we are going to come up with a cosine function, then now I'm going to start looking further into the information. So the center line is now clearly here at 13. We have a center line at y equals 13. And the amplitude being 8. Because, once again, the wave swings 8 units up, 8 feet up, and 8 feet down. The tide goes 8 feet up from the mid-tide and 8 feet down from the mid-tide again. And that's how I've recognized the amplitude here as being 8. So in that way, I can partially complete my modeling function here. It's 8 times cosine of A in parentheses t minus c plus 13. Okay. And now with the period, one complete cycle is given to be 24 hours per period. And further, I have stated that we chose the starting point right, to be at t equals 0, but that's corresponding to 6 a.m. t equals 0 is here. Okay, then we can now complete our equation. Again, 2 pi over a is always known for any general period of a sinusoidal function, sine or cosine. But in this case, our general period, for this sinusoidal function will equal the given 24. Solving this equation, we're going to lead to a must equal pi over 12 after solving for it. All right. And so in that way, my equation is further completed as 8 times cosine of pi over 12 times t minus the starting point, and then plus 13. And so now the starting point, since the starting point is chosen to be 0 right here, our function now is completed as y equals 8 times, see, we substituted 0 into the c right here. So now we have cosine of pi over 12 times t minus 0, it's just t plus 13. And so now our modeling function can be also written. So we have seen how we have written with the modeling function as a different function, and now there's the same exact data right there, but we can come up with a different function. It all depended on how we chose, right? We can choose the starting point, and that came up with a different function. So now here we have 8 cosine of pi over 12 t plus 13. That's a different way of how I can come up with this, the modeling function to model the exact same the tide. All right, then so in that case, once we have if we have come up with the modeling function as a cosine function, let's see how we can answer this question. Find the tide at 7 p.m. of the day. And so now, since we chose our starting point to be the 6 a.m. point right there, then 7 p.m. is 1 hour past this halfway point on our chart. So again, it's all due to the fact that because we chose 6 a.m. to be our starting point, t equals 0, then 7 p.m. is going to be 1 hour past that 6 p.m. point on our scale right here. And so in that way, that means 7 p.m., the same exact time point that was asked for in the problem, is understood as t equals 13 hours. Because from 6 a.m. the starting point to the immediate 6 p.m. it's 12 hours away, and then 7 p.m. is one more additional hours. It's t equals 13. All right. And so now the problem now really means we need to find the height of the tide at 13 hours later after the starting point. So in that case, I am going to substitute 13 into the function here. We have 8 times cosine of, there's a pi over 12 times 13 close that parentheses and add with another 13. And again, we're going to keep everything in radians. Okay, and now with the calculator, 8 times. Now I'm using the cosine function. In parentheses, we have a pi over 12. So that's how I can group pi over 12 as one fraction and multiply with 13, the value that's substituted for t. We close our parentheses for cosine and we add with 13. And I already changed the setting to run the cosine value in radians. The answer came out exactly the same as how we've had that earlier. So now in 2 decimal places, again, the truth is just one truth. So the height would come down to 5.27 feet at 7 p.m. So it's exactly same result with them. All right, so after seeing what I have done with that particular demonstration problem right here, allow me to point out the general guidelines right here for how we can come up with a modeling function to model any quantity that changes periodically. Okay, so the first step that I did there, the first step really was to set the highest line and the lowest line like that. So, or the highest value and the lowest value. That's what I did when I was setting the high tide was being a 21 and the low tide was being a 15. And so because of that, consequently, right exactly in the middle, we can identify the midline, the center line. And so in that way, my next step, you have already seen. So the next step there, I put the center line at the middle, exactly in the middle between the highest points, the highest line, the highest value, and the lowest value with them. And that's how we have our eventually center line. The third step now. The third step now is to choose, and you have seen me doing that on the board earlier. The third step there, I was choosing, or I would look for a given starting point. So either you choose a starting point on your own, you have your control over that. You can choose a starting point, or you can look for a given starting point according to the worded description of the problem. And now it comes the fourth step right here. And now the fourth step here is to plot all of the given data points on our graph that we have created. And in step 5 right here, we would fit a sinusoidal graph through the plotted data points from the previous steps. And then from that sinusoidal graph that we have fitted in, we can recognize it as either a sine or a cosine. And so it's important that you choose a starting point and then you put in the data points, and then we fit a waving graph through these plotted points. And that's how we can lead our attention into deriving that as a sine or a cosine function. And then that is the general structure, the general guideline of how I would recognize a modeling function like that. And this skills here is particularly once you have fitted a sinusoidal graph through the plotted points, you are required to bring in your skills in terms of how you can recognize a sinusoidal graph as a function, sine or cosine.